I'm R. Prabha, Assistant Professor in the Department of ECE, SNS College of Technology. In this video, we will discuss the topic on log periodic antenna. The log periodic antenna is otherwise called as log periodic dipole array, that is LPDA, and it is a wideband directional antenna that provides gain and directivity combined over a wide range of frequencies. A log periodic antenna is that whose impedance is a logarithmically periodic function of frequency. The geometry of the log periodic antenna is so chosen that electrical properties must repeat periodically with the logarithmic of frequency. The frequency range in which the log periodic antennas operate is around 30 MHz to 3 GHz, which belongs to very high frequency and ultra high frequency range. The log periodic dipole array consists of number of dipole elements. These progressively reduce in size from back to the front in the direction of maximum radiation is smaller from the front. And the active region, that is the sections of the antenna that are contributing to the transmission or reception, vary with frequencies, and only about 3 may really contribute to the radiation at any given frequency. There is also a smooth transition of the active region of the LPDA along the array as the function of frequency of operation changes. Each dipole element of the LPDA is fed, but the phase is reversed between adjacent dipole elements. This ensures that the signal phasing is correct between the different elements. It is also means that a feeder is required along its length of the antenna. Normally, this is arranged so that it forms the part of the mechanical structure of the array. So, the working of the LPDA is when the signal meets the first element of the antenna. The first element here refers to the element which is closest to the front, that are smallest. And it will be found that they are spaced close together in terms of the operating wavelength. As the feeder sense is reversed between the elements, the fields from these elements will tend to cancel out and no radiation will occur from these elements. So the RF signal travels along the feeder. In the antenna, it reaches the point where the feeder reversal and the distance between the elements gives a total phase shift of about 360 degrees. So at this point, the effect which is seen is that of two phased dipoles. So the signal from adjacent dipole is in phase. The region in which this occurs is called the active region of the log periodic antenna. Although the example of only two dipole is given, in reality the active region can consist of more elements. It may be 3 or more. The actual number depends upon the angle alpha and the design constant. So behind the active region, the signal again falls out of phase and no radiation occurs. The elements outside the active region receive little direct power. So by observing the design equations, the parameter ratio, the length ratio of adjacent elements Ln plus 1 by Ln and Rn plus 1 by Rn, and spacing Sn plus 1 by Sn, and the distance Dn plus 1 by Dn and equal An plus 1 by An is equal to 1 by tau. So n is equal to 1, 2, 3 up to n. Here An is gap spacing at dipole centers. Spacing factor is called as sigma, and this sigma is Rn plus 1 minus Rn by 2 In. It is equal to Sn by 2 Ln. So here Rn is distance of the dipole from the origin. The dipole length increases along the antenna so that the included angle alpha is constant along the length, and spacing S of adjacent elements are called so that Ln plus 1 by Ln is equal to Sn plus 1 by Sn is equal to K is equal to 1 by tau. So here K is constant and alpha is called as apex angle, K is the scale factor. And for 5 elements dipole array, K equal to 1.19 according to the formulas we have seen already, and the frequency ratio is 2.1. The element 5 is twice the length of the element 1. The design of the LPDA involves the determination of the spacing factor sigma and the scale factor 1 by k. The spacing factor gives the successive dipole spacings and the scale factor determines the length of the successive dipoles forming a wedge-shaped cone. So the advantages of the log periodic dipole array: the antenna design is compact and the gain and radiation pattern are varied according to the requirements. Disadvantages: it is extremal mount, installation cost is high. Applications: and these log periodic dipole antenna arrays are used for high frequency communications, used for particular sort of TV receptions, used for all-round monitoring in higher frequency bands. So the assessment question: log periodic antenna uses which range of frequencies? It is very high frequency and ultra high frequency. And the second question: which of the following best suits to describe the impedance of a log periodic antenna? It is the function of logarithmic of frequency. Thank you.